Thank you for coming out this afternoon for our session on Kiro. We'll be talking about how to build applications, and we're going to be building a live application in front of you here this afternoon. So I am Ryan Yanchalev. I'm one of our specialist solutions architects here at AWS. I'm part of the next generation developer experience team. So we work with customers who are looking to roll out generative AI development tools inside of their organizations. And with me, I have Ryan.
And I am also Ryan Bachman. Same team, same responsibilities, same everything that he just said. Just a quick, as we get into the session, who's done a code talk before? Anybody, like, quick raise of hands? Anyone done a code talk before? Okay, these sessions are really meant to be interactive. So while we are going to be doing live coding, I also encourage us to engage, learn from each other. I'll be walking around as he's presenting and coding. We'll have some dead time, ask questions. I'll go ahead and amplify that question, and we could kind of talk about it, right? Whatever you want to talk about, learn. We're here to talk about agentic AI or spec-driven development as well with Kiro. So yeah, that's just, feel free, share your opinions, share your thoughts. I will be polling the audience numerous times today. So,
yeah, we are going to be building an application from scratch inside of Kiro live on the screen, and we're going to build an application that you guys and gals recommend. So Ryan's going to poll the audience here in just a minute, and we're going to take like the 2 or 3 best ideas, and we're going to build them live here on the screen. Well, we'll build the best one live on the screen. So be thinking about that as we walk through the next couple of slides here. So before we dive into it, want to just kind of set the stage, talk a little bit about what Kiro is so that everybody's familiar with it. It's a relatively new product that we released this year, and it just went general availability about 2 weeks before today. So with that, one of the questions that we get asked a lot is, why did we build another tool? There's a lot of them out there. So why did we build another one? And I think it's helpful to kind of understand where things have gone and how they've evolved. So if you go back a couple of years, we started out with generative AI that just did sort of general helping. It was a glorified IntelliSense, autocomplete, simple chat questions and interactions and things like that. And then more recently, we got into a situation where we could do assistance. We could say, hey, I want to go and make a change to this function, or I want to go and debug this particular log file, or help me out with this thing. Very specific tasks that we could, again, ask the generative AI tools to go in and help us with. And then in the current age, we have what we call agents, which is where I take more complex problems. I say, here's what I want to do. Here's what I want to build. I want to build an application. I want to add a new feature to my existing application. I want to modernize this part of my application. I want to migrate this piece of application code. And I need you to help me out with that. And that involves multiple different steps. I've got to run things on the command line. I've got to talk to third-party tools. I've got to generate code. I've got to modify existing code. And we call this agentic development. The term agentic gets overloaded a lot, so I think it's helpful to kind of understand what we mean when we say that. So the promise here was that we get autonomy. We could all go sit on the beach while we let the generative AI tools go and write code for us. We get more collaboration. We have a back and forth conversation with this generative AI tool. And we chat along and we tell funny jokes and we get work done, just like you do with your other coworkers. And then we, of course, get high quality code. Nobody's producing junk when we do this, because we're all professionals. And so this is the promise. The challenge, though, that we saw with customers starting to use these tools in their production environments centered around 3 major things. And it was these 3 major things that we set out to solve for when we built Kiro. And these 3 things really are laid out here for you on the screen. The first one, and the biggest one, is how do you scale? So it's great when I want to build tic-tac-toe and I'm just one developer in a corner hacking out some code. But when I have an existing production application with 1.2 million lines of code, and I've got a team of 150 developers who are all working together, this becomes really important. Because I need my LLM to be able to understand all that code. I need it to be able to understand that code consistently, and I need it to be able to produce similar results for all 150 developers along the way. It does me no good if the non-deterministic nature of the LLMs creates working solutions for all 150 developers, but it does so in very incompatible ways, which is possible when you think about the non-deterministic aspects of generative AI. So how do we do this at scale? How do we solve for large development teams, and how do we solve for large existing code bases? The other piece is the idea of control. We talked about in the previous slide about this true collaboration concept, but that's not really what we have in generative AI. What we have in generative AI is we take this prompt that we kind of concoct and throw into the chat box, we throw it over the wall, and we say, make me something. And it goes off and it writes 1,000 lines of code, and it says, I made you something. And then it hands it to you, and hopefully it did it right. But more than likely, what happened is that it got to a lot of different decision points, a lot of details that you left out of your prompt that it now has to go and fill in the blanks. And maybe it got it right, maybe it chose the option you would have chosen, maybe it didn't. But now it's up to you to figure that out. And now you've got 1,000 lines of code that you've got to go and figure it out with. And then the last piece is, when you take those two factors together, both of those negatively impact the overall quality of the code. What you're getting is code that you don't really want. It doesn't really do what you wanted it to do, and it doesn't really do it the way you wanted it to do, and it does it differently for all the different developers on your team, which is not helpful. So what we created for Kiro and what we tightly integrated into the solution is something that we call spec-driven development. And it's a return back to first principles of software development. We don't bring a team of developers into a room, write 4 bullet points on a whiteboard, and say, guys, we'll check in on you in 6 months. Let us know how it goes. That would be chaos, and for good reason. What we do is we step back and we say, all right, well, what are the requirements? Let's detail those. Let's bring in our stakeholders. Let's bring in all the key players and lay that out. Then we say, all right, well, these are the requirements. How are we going to build this? And we build a design document. And we say, what are all of the different design specs and the technical details? And we lay all of those out, and we bring in all the stakeholders. And then we say, all right, well, what is the project plan? And we build one of those fun Gantt charts with all of the different tasks that we can do in parallel and in serial, and we lay those things out. And then once we have those, then we bring the team of developers in the room, and we say, here's what you're building, here's how you're building it, and here's all the different tasks that you need to do. And we use those to go off and actually do the implementation. And that's how we solve for this problem of building at scale. So what spec-driven development does is it takes generative AI and it applies the same model. It says, give me your prompt that you concocted that's missing a lot of details, and instead of going off and writing 1,000 lines of code, I'm going to go and I'm going to generate a requirements document. And then I'm going to generate a design document. And then I'm going to generate a project plan. And you're going to have the opportunity to review all those things because they're just text documents. And then when you're happy with all of those, then we'll start building. And whether it's just you on a greenfield application, like what we're going to do here in a moment, or whether you've got a team of 100 developers and hundreds of thousands of lines of code, we're going to get very similar results because we're working with the same context, we're working with the same details, and we've had a chance in advance to review all of the different details that might have gotten left out from your prompt, and we can fill in the blanks and we can validate them all, and then we can move on. And so that's what spec-driven development is, and that's really what makes Kiro unique. So if you could build an application and take advantage of that, how would you go about doing it? And so this is where we're going to switch over, and we're going to switch to a live coding demo. And so I'm going to need some ideas because I've got a blank, empty screen, and I need something to build.
Yep.
So bonus points.
Anybody that's been to like an improv show, I'm going to try this out. Like, you know, you shout out like random ideas, and then we're going to maybe combine a couple or two. So like, this is where we need the audience. So like, don't raise your hand, just like yell out. What's that? All right, fitness app. Anyone else?
That focuses on the trainer.
Fitness app that focuses on the trainer. AWS what? Now?
Event app. Event manager. That's my app.
Is that your?
I came up with that app.
All right. Any other?
That's what I normally do in my demos.
Can we combine? I don't know how to combine those two. Virtual concierge? Oh, hotel.
There you go.
All right, so we got a fitness app, concierge app, and I don't know how to combine all three of those. It's a.
All right. Let's see. Well, let's see what we can come up with here.
How about a fitness app?
I want to build a web application
on the
to
trainer,
manage
like-
my fitness activities and determine if I actually did them and how many calories I burned in the process. All right, we have 40 minutes, so I'm simplifying this down a little bit. But okay, so here's my prompt. If you look at that prompt, you can tell pretty quickly right away that there's a lot of detail missing here. I have specified that I want a web application. I have not specified what I want it to be. Could be React, could be Python, could be .NET, could be some esoteric language from 40 years ago. We haven't really defined that. We haven't specified a lot of things in here like, do we want authentication? That's probably a good idea for a personal fitness app. We haven't specified what a lot of the features are. We haven't defined whether we want a full stack app with a data layer and a business layer and a front layer, or whether we want to build this all together like a Next.js app, for instance. We haven't said if we want it to be mobile. Well, actually we did. We said we want it to be a web application, so we specified that. But you get the point. There are a lot of details here. And in Kiro, I have the ability to switch between two different modes. So if I were to put this into Vibe mode, which is what you get from a traditional generative AI tool, and I were to hit go here, it would go off and it would immediately start building. And what would it start building? Well, it would figure out some strategy to build a web application. It might pick React, it might pick Python, it might pick something else. And if there were 5 of us up here on stage, it might pick something different for each one of us, because generative AI by definition is non-deterministic. So we're not guaranteed the same results. But I'm going to put it into spec mode, and I'm going to kick this off. And so what's going to happen now is that Kiro, instead of going off and actually writing the code, is it's going to start generating what we call a spec. And a spec here is going to define what it is that we want to build before we actually start building it. And so we're going to let this run in real time to kind of give you a sense of how much time this actually takes. The spoiler alert, it doesn't take very long, assuming that our network holds up here. And so it's going to create for us a requirements document. And you can see here, it's opened it up for me on the screen. And so I've got my requirements document on the screen here. And this requirements document starts out with a high-level introduction. So it's given me kind of a general summary of what I put in. I wrote one sentence into the prompt box here. I've gotten a paragraph of details that are laid out. I've also gotten a glossary of terms so that we are clear on what we're talking about. It's laid out a lot of different details like what's a user, what's an activity, what kind of activity types are there, how do we calculate calorie consumption, how do we deal with the activity logs. All of these different things here are laid out. These are all important things if I'm going to go and build this application that I didn't specify in my original prompt. And then we're going to get into the meat of this, which is the requirements themselves. So each requirement is going to have a user story, and it's going to have a set of acceptance criteria. And so the user story combined with the acceptance criteria is going to detail all the different things that I want. And you can see here that it came up with 7 requirements, which is not bad considering that I gave it one sentence. Now, is that enough requirements to build a full-fledged web application for fitness tracking with auth and all of those other details? Probably not. But it does get us quite a bit farther down the road than we would have been if we had just taken this prompt and thrown it over the wall. And one of the things that's important to understand about specs is that they're not really designed to be used to write an entire operating system. You want to use something like a spec to do feature development. So our application here is going to evolve over time. There are going to be things that we want to add to it. There are going to be things as we show off our initial MVP to our stakeholders. There are going to be things that they're going to say, well, this is really cool, but I want to add this thing. This is really cool, but I want to change this piece. I hate this thing. I can't believe you built this. And we're gonna go a couple different routes here, and we're gonna be able to evolve as we go. So we've got our user stories here, and they follow a specific format. They follow what we call EARS. It's an industry standard for writing requirements. It's easy, accessible requirements system, spec, something like that. I never remember what that acronym stands for. But it follows that key system, which is that it creates a user story and then it creates acceptance criteria. And so what we can do now is we can say, all right, let's review this. Do we like this? Does it capture the things that we want? Did we think of something else in the 5 minutes that it took to create this document that we want to add to this? And so we can evaluate and iterate on this, and we can make adjustments. For the sake of time, I'm going to leave it here as it is, but it says here, like, as a user, I want to create and manage fitness activities. That's a good start. That kind of aligns with the prompt that I have here, so that I can plan and track my exercise routines. Cool. I want to mark the activities as completed with their actual duration, so that I can track what I actually accomplished. And you can see here that each one has acceptance criteria. So when a user creates a new activity, the application should store that activity with the details, with the type, with the planned duration, with the planned date. All of that information should get tracked. Maybe I want to add another attribute there. Maybe I want to track location as well. And so now is my opportunity to come in here and make an adjustment. And I can say I want to add location to my data that's being stored. All I'm doing here is modifying a markdown file. So once I'm happy with the requirements, I move on to the design phase. And I say, all right, well, this is great, but now I want to know, how am I actually going to build this? What language am I going to write it in? What libraries am I going to use? What am I going to do for authentication? How am I going to handle error handling? What am I going to do for testing? All of these different details need to be captured here. And so we gave it no details except for a web application. So we're all going to find out together what this thing actually decides to build and how it decides to build it. And this is going to be our opportunity to say, no, I don't want to build it with Python. I want to build it with React. I don't want to build it with React. I want to build it with Go. I want to build it with a SQL database. I don't want to build it with a SQL database. I want to build it with NoSQL databases. This is my opportunity to correct for all these things. Because at this point, if we, again, just threw this over the wall with vibe coding, the LLM would make those decisions for you. It would say, you didn't tell me what kind of database you wanted. I feel like SQL today. I'm going that route. And if you wanted NoSQL, you're out of luck. You're going to have to go back and rebuild that code after the fact. And so that creates complications, and it takes time to evaluate for all of those things. So at this point, we're going to get an evaluation. And you can see here, one of the things that it's doing is it's saying that it's formalizing the requirements for correctness properties. What this is, so Kiro has a feature in it called property-based testing. And property-based testing is a really fancy term for essentially testing with edge cases. But it's going to evaluate my requirements, and it's going to say, what are the things that need to be checked for? How am I going to check for them? And not just the happy path, but what are all the edge cases? You say that you want to know what your planned duration is for your activity. Well, what happens if you enter a bunch of letters into that field? What it's going to do? Is it going to give you an error? Is it going to crash? Is it going to blow up? How's it going to handle that? So that's just one example, but you can see here that it's looking at the different prompts there, or the different requirements, and it's saying, all right, well, what do we need to do to test for all of that? And so when we go now and we look at the design document, what we have here is another summary at the top with all of these details. We have more architecture. So we have a foundation layer, we have a business layer, we have a data access layer, we have our browser's local storage, we have a tech stack. It looks like it's using React with TypeScript here. That's what it settled on. It's going to use the React Context API for state management. It's going to use Tailwind for my UI. So a lot of different things here are being specified. And again, if I don't like any of those things, it's pretty simple. I just go in and modify this application, this document here, and I'm good to go. So it's going to lay out, again, the stack for all of the different models that I have. We're going to get into the data layer. We're going to get into the correctness properties. And all of the different ways in which we're going to do that. So what happens if I have a planned and, stop that. What happens if we have a planned and actual duration, and do they both get preserved? So how are we going to calculate that? What are we going to do for triggering the calorie calculation? A whole lot of different details there. Then we get into error handling, input validation. We get into business logic errors. We get into testing strategies, including employing all of those different property-based tests that we outlined above. What do we do for unit testing and integration and test execution? So there's a lot of detail here that's captured. We've got some questions over here.
So question was two things. MCP servers, is that the default? Or did you add those? And also agent steering, what is that?
Okay. So just, I mean, for the room too, if, so the questions are, we have some MCP servers that are configured, you can see in this video, and then also agent steering. What is agent steering?
Yeah, so the MCP servers I installed. So by default, Kiro doesn't come installed with any MCP servers. It has support though for local MCP servers and for remote MCP servers. So you can go through the remote MCP server flow, you can do OAuth to connect to your remote MCP servers if you want to do that, or you can install local MCP servers and you can configure them. I have these installed at the user level, which means that they work for all of the different projects that I open. You can also install MCP servers at the project level, so they're only relevant to the specific project. So these MCP servers here happen to be installed locally on my machine. I don't know that we're necessarily going to use them over the course of our demo here, but you can install whatever you want. They don't come pre-installed. Now, the question about agent steering. So over here on the left-hand side, this is my Kiro panel here on the left-hand side. I get to it by clicking on the little ghost here. Kiro by default is a VS Code fork. So if you're looking at this going, this looks pretty familiar, it's because it's a VS Code fork. And so a lot of the UI and elements here are going to be very familiar to you. But there's a section here at the bottom with the little ghost that brings up the details that are unique to Kiro. And you can see here at the top, the spec that we're working on is listed here. And so I can see the spec that I have here. I can create as many specs as I want. So I'm not limited to one spec. I don't have to try and build my entire project in one go. I can create multiple different specs and I can track them all as I go along. We'll finish this one out here in a moment. But down here I have agent steering. So what is agent steering? Well, if you've used other generative AI tools before, you're familiar with the idea of context, or you're familiar with the idea of rules. So in QDeveloper, for instance, we have the idea of rules. What a rule is essentially just a piece of context that sort of provides guidelines for the LLM to follow. Whenever you document, or whenever you write a function, I want you to include a comment block that looks like, XYZ at the top of it. And so that's a rule. I want Kiro to do that for me. Steering documents, though, and particularly this button called Generate Steering Documents, deal with one of the challenges that we talked about in the slide presentation, which is how do I deal with projects that have existing code? How do I deal with a project that has hundreds of thousands of lines of code? Well, in order to do that, what I need to do is I need to document that somehow. I need to create some context around it. I need to summarize it. And I need to make that available to the LLM in the form of rules or context or something like that. And so what Generate Steering Documents does is that the first time whenever I open up a new code base in Kiro, and by new here I mean new to Kiro. So maybe I've been working on this project for 10 years, but I'm going to open it up in Kiro, and I'm going to go down and I'm going to hit that Generate Steering Documents button. And what it's going to do for me is it's going to reverse analyze that code for me. So it's going to go through all of that source code and it's going to summarize it for me. And it's going to say, all right, here are the details that I need to be aware of when you ask me to make a change to this code. And so it's going to create a file called a product. And the product file is a natural language summary of the code. It's a layout of what is this code doing that I, as a reader, as a human, could quickly pull up and say, all right, give me a summary of what this 800,000 line code project is doing. And I can read through that. Then it's going to build a tech file. And the tech file is really going to mirror what our design document file looks like here. It's going to be the tech stack. What language is it written in? What libraries is it using? What's its strategy for error handling? What's its strategy for testing? What are the commands necessary to boot the dev server? What's the command necessary to run the test suite? All of those different things are going to get captured in the tech file. And then it's going to build the, am I blanking on the last name? The product file, I think is the last file, is essentially the roadmap. And so the roadmap file is going to lay out, here's the directory structure of this project. Here's all of the different directories. Here's the code, the files that are in each of these directories. Here's what's relevant about each of these directories and each of these files. Here's the major classes and modules and elements inside of these. And equally as important, if I ask you to make a change to this particular module, what's the blast radius? So I ask you to make a change to the authentication component in my 800,000 line project. If I go in and modify that, how many other things in this project are going to be impacted by that change? And in order to know the answer to that, I need to know what the spider web looks like of how these different modules interact with each other. And so Kiro is going to capture all of that information for me in the form of these 3 steering files. And it's going to do that for me automatically when I press that button. But that steering directory is open-ended. So I can add whatever other things I want to add there. So if I have a rule about how I do software development, I can generate that and add it to the steering directory. If I have a rule about, or if I have information about a third-party API that I talk to, and I want to be able to be aware of that, I want the LLM to understand, how do I use that API? What does it do? How does it work? I can document that and add it to the steering directory. And all of these files, they live, if we go back to the File Explorer, they live inside of this .kiro directory at the root of my project. So you can see here, we're starting out from scratch. I don't have anything in my File Explorer yet except the specs that I created. But as we start generating out more code, this will all get captured in here as we go along. So, does that answer your question? Perfect.
Sure. Yeah, so you mentioned that we're not going to build an OS ever in like this sort of like single prompt fashion, which like from a process perspective totally makes sense. Small increments and like a human needs to also understand the increment we're working on. But are there like technical limits? We are blurting out a lot of context there. Is this going to eat into some sort of context window? Is there going to be like a technical limit to run this work?
Yeah, so the question there is there a technical context limit that we need to be aware of? And just like every LLM, there are there's a context window that applies. Kiro has a 200,000 character context window at the moment.
Token.
Token. Sorry. What did I say? Character?
Yeah.
Sorry. Token window. We have some plans to release bigger token windows as the models are evolving, the token windows are expanding, and so the product is kind of evolving along with that. If you get to a point where your token window is full, Kiro will ask you if you want to compact your current session down and start with essentially reset your context window. But one of the things about using specs and using them with steering documents, to the question that was asked earlier, is that the combination of steering files and spec files is a really powerful combination in the sense that all of this information is already documented largely in these markdown files. So if I need to reset my session, if I want to go on vacation and come back on Monday, I can do that, and I haven't lost a whole lot because I'm detailing everything here in these static files. And I can share these files across the team. So if somebody else needs to come in and pick up where I left off and do it from their own machine, we don't need to worry about transferring the session details because we've captured all of the major important points in these markdown files. And so that's why, that's a big part of why we're doing this, because again, we want to work on collaboration. We want to be able to make sure that every member of the team is working with the same context and moving in the same direction, so that we cut out all of those variables. So to keep things moving here, I'm going to move from the design document now, and I'm going to move on to the implementation plan. And while it's doing that, if we have more questions, I can certainly answer those.
Yeah, I have a question. So
So just echo. So the question is, how does this interact with something like Jira for like product management and stuff like that? Like, what's the interaction look like?
Yeah, so you've got as an organization, my product managers are writing their user stories in Jira. And I want to be able to use spec-driven development, but I don't want to create multiple sources of truth. I don't want to take what's in Jira and replicate it into my repo and then have to deal with drift and the potential of things splitting apart. And so the way in which you solve for that is twofold. One, you can install an MCP server. So I can install the Jira MCP server, and I can integrate that with my Jira project. I can enter my credentials. I can use a remote MCP server. I can use a local one. And I can enter the details for my Jira project. And then in the prompt here, I can say, hey, go get the user story ABC, or go get the user story for adding the authentication module to my application, and pull that in. And so what that does is it goes and it gets the information from Jira, and it pulls that information in, and it reads that information, and it uses that to create the spec. And so that's how I bridge that gap from Kiro to Jira. But that doesn't necessarily entirely solve my problem. It does get me access to that information, and it helps me build the spec so I don't have to write or copy paste all that information into the prompt block. But what happens if I make a change to the design document, or what happens if I make a change to the requirements document? I say, I want to tweak one of these user stories, or I want to make an adjustment to one of these acceptance criteria. I want to be able to reflect that information back into Jira so that my data is staying in sync, so that I'm not creating that drift situation. And the way in which I do that is using the last feature of Kiro that we haven't talked about yet, which is agent hooks. And so what agent hooks are, and I'll create one for you here in a moment, but what an agent hook is essentially an event-driven prompt. So I take a prompt, and my prompt in this case would be, whenever there's a change to my requirements document, I want you to summarize that change and reflect it back to the appropriate user story in Jira. And I want you to run this prompt automatically whenever there's a change to a requirements.md file. So whenever you detect a file save event on a requirements.md file, summarize the change and push it back to the appropriate Jira user story. And so what this does now is it creates a circular feedback loop. So in the prompt, I say, go get the details for user story, the user story related to my auth module, and pull that in and generate the spec for it. And then when I go and I make a change to one of the acceptance criteria in that spec, my agent hook says, I detect you made a file save event in your requirements document. I'm going to go and summarize that and push that change back to Jira. And that's all happening, that connection there is happening via the MCP server. The MCP server doesn't just allow me to read information, it also allows me to write, assuming I have the correct permissions to do so. And then it summarizes it and it pushes it back. And so now I have my user stories are staying in sync with my third-party tools. So things like Jira can be managed that way. I can also do this if a lot of companies have their design standards or their software development standards documented in something like Confluence. Or they have an internal wiki, or they have a SharePoint server that lays out how we do design, how we do software development, how we do all of those things. And we can solve for that as well with an MCP server that connects to that, and then a steering file that says, hey, whenever you generate a design document, make sure you go and refer to our design standards or our architecture standards available at this MCP server, and use that information so that you're not just inventing some standard for how you want to do for how you want me to do software development. Use the standards that I've already established. So that's how you would go about kind of creating that feedback loop. So we can see here now that we've created our requirements, we've created our design, and now we've created our task list. So our task list here is essentially the project plan. What are the things that I need to do to go and implement these requirements to this particular design standard? And what Kiro comes back with is it comes back with this list of things that need to be implemented. And it's fairly exhaustive. We have, 18 tasks in this list. And you can see that some of them are grayed out. Some of them are bold, and some of them are grayed out. And some of our tasks have subtasks, like task 2 has a task 2.1 and a 2.2 and a 2.3. Some of them are grayed out. What that means is that some of these tasks are optional. So Kiro's going to make a distinction here for me now, and it's going to say, all right, well, are you building an MVP? Do you just want something quick and dirty that you can kind of test out and see what it looks like? Or are you building a production-grade application, in which case we need to make sure we cover all the bells and whistles? And so it's going to ask me here in the task or the execution log, which one are you making? Are you making a quick MVP, or are you making a comprehensive production app? Since we're pressed on time here, I'm going to say we're going to make a MVP, and I'm going to leave those things optional. And really, those tasks are around testing, and they're around documentation. Our quick and dirty MVP application here doesn't need a robust unit testing and documentation strategy for it. We just want something that we can test out and give it a try. And if we look at these individual tasks here now, we can see that each task has a checkbox next to it that's going to track our progress. It's going to make sure, it's going to tell us, is this task done? Is it in progress? Has it not been started yet? It's going to lay out some of the details that that task involves. And then in blue there at the bottom, it's going to say, well, which of the requirements are we fulfilling by doing these particular tasks? So we're going to get some traceability here from the requirements to the actual implementation. So the first task here has a button at the top of it that says Start Task. And when I click that Start Task button, it's going to go now and it's going to switch from spec mode and it's going to switch into vibe mode. So when I click the Start Task button, it's actually going to go and it's going to start actually producing the code to implement this. So this is going to involve running commands. It's going to need to be able to set up React. It's going to need to be able to configure TypeScript. It's going to have to install the dependencies. And you can see here now that it's going to get started on that. So it's going to start out by running the create vt command, and it's going to ask me for my permission to do so, because it's about to run a command on my command line. So it's going to make some changes to my local code, or to my local environment, and I'm going to have to approve this. And so I can either accept this command, I can add this command to a trusted list of commands, essentially saying, I'll give you permission to this, and don't ask me about this again. So the next time you come across a command that looks like this, go and do it automatically. Don't ask me. I can reject the command, or I can modify the command. So here, for to keep this simple, we're going to go ahead and run the create, or we're going to go ahead and tell it to run the command. And we can see right here, it ran into a problem. I have Node installed. Why is it not? All right, well, it's in its effort to be helpful here, it's going to try and figure out how to do this automatically without the fact that I have Node installed. We're going to let this run, and we'll see how it goes. But essentially what it's going to do here is it's going to kick off. And you can see that it's running in the terminal window here at the bottom. And it's going to start to generate the files that are necessary. So it's creating the vt config file. It's creating the TypeScript config file. It's creating a gitignore file and the package.json and all of the different things that are necessary here. So it's creating our main file, our app.tsx file, our index. So it's going to go through and it's going to create the structure for my application. And if we switch over to the File Explorer here, we can see that it is generating all of the different files in our repository here. So we're getting all of these things built out for us as it goes along. And we'll figure out why it can't find Node here in a moment. But it's going to go through this, and you can see in the task list here that it marks this as task in progress. And we've got a little hash here in the checkbox denoting the fact that this is in progress. And we can view the changes here that are happening in a git diff. So if I click on this, I can see all the different files that are being modified and the changes that are being made to them. And since we're starting everything from scratch, this is not going to be a particularly exciting diff to look at, but you can see here exactly what's happening. And when it finishes, we'll be able to look at the execution log as well. So now you can see that the task is completed. We can view the changes, and we can view the execution log, which means we can come back and we can see what exactly happened in the execution log. What commands did it run, and what were the results of those commands? Notably, we'll figure out that, surprisingly, I don't have Node installed on my machine, and the issue that created. And so it works through that. At the end of this, too, it also tells me how many credits it used and how much time it took to run. So this particular command or this particular task took 2.3 credits. You'll note the decimal there. Credits can be consumed in partial fractions. So it's not going to charge me for 3 credits, it's going to charge me for 2.3 credits rather than rounding up. And it took 2 minutes and 59 seconds to complete. And so we've got our task here. And so the task now, if we come back to the file explorer, these files are captured in the repo. So now I can go and I can do a git commit, and I can check this code into my repository, and I can say, all right, here are the specs that I'm working from. And so if I have multiple developers, I can say, all right, well, I want this developer to do task 1, and I want this developer to do task 2, and I want this developer to do task 3. And I can divvy out the workload. But they're all working from the same requirements document and the same design document and the same task list. So we're all moving in the same direction. And if we had an existing code base here, we could say they're all working from the same steering documents as well. So they all have the same understanding of that core code base. We're not relying on 3 different inferences of the LLM to draw the same conclusions about that existing code. It's all happening, and it's documented, and it's shared across the team. So we get that collaborative nature that we were talking about. Now, somebody asked about what do we do with agent hooks? And so with an agent hook, I can come in here and I can say, all right, I'm going to create an agent hook. I'm going to say whenever a change is made to a requirements.md file, summarize the changes and reflect them back to the associated Jira user story. And I'm going to kick this off, and what I'm going to do is I'm going to tell Kiro to go and create a hook that does this. Now, I specified what I want the hook to do. I want it to summarize changes and reflect them back to Jira. And I told it what files I care about, namely the requirements.md file. It's going to go off, and it's going to do the rest here. That looks, I love live demos. So we can see here in the hook panel, it's created a hook here with a title, Requirements to Jira Sync. It's created a description. This is going to monitor the requirements.md files, and it's going to automatically summarize those changes and reflect them back to the associated Jira story. It's going to look for a file save event. There's a couple of different options in here. I've got file created, file saved, file deleted, or a manual trigger. Essentially, that's just a saved prompt. A manual hook is essentially just a saved prompt that I can run whenever I want to kick it off. It's going to tell me the file paths to look for. It's going to look for anything that's called requirements.md. I could tell it to look for any file in a particular directory. I could add multiple different things that I want to look for. And then we get the actual prompt itself. This is the prompt that it generated based on that input that I gave it. So a requirements.md file has been modified. Please analyze the changes, summarize the changes in clear and concise way, identify the associated Jira story, and then push the changes up to that Jira story when you're done. And so we've got now an agent hook. And just like my specs and my steering files, these hooks get stored inside of this .kiro directory. So I've got my hooks here as well. What that means now is that all of the users on the team have the same hooks. All the developers now have the same specs, they have the same steering files, they have the same hooks. And so everybody is working from the same set of information. And this is how we solve for, again, scale. It's how we solve for collaboration, and it's how we solve for visibility into the actual understanding of what the LLM is going to do. So how is it going to behave? What are the things that it's going to perform? and how is it going to go about and actually perform them. Want to open it up for some more questions?
Yeah, we got it.
We are unfortunately not going to have enough time to actually build this entire application in the next 15 minutes.
So care to do it.
And Kiro is spitting a little bit of gibberish here anyway. But
This process is because it has to be repeatable, right, for everybody?
Yeah, so the question is, how deterministic is this process?
so LLMs are, as we've said a couple times now, LLMs are by definition non-deterministic. The way in which you make them more deterministic is to provide more context. So the more guardrails and guidelines and context you can provide, the more consistent the output you'll get. So if I say, for instance, generate a web application, and that's all I say, and I ask that 5 times, I'm going to get I'm going to get a React application, a Python application, a Rails application, maybe another React application. I'm going to get a lot of variability there. But if I add context and I say, generate a React application, all 5 times it's going to generate a React application for me. So the point being, the more context I provide, the more detail I lay out, the more deterministic the output will be. And the challenge with that is that historically, writing the context of these 3 spec files into the prompt every time I want to do something is it's not particularly scalable, because the more expansive I'm trying to build, the more details there are and the more gaps I have to fill when I generate that prompt, and I have to rely on every member of the team to do that, which is not realistic. So what we're trying to solve for here is we're trying to provide that context up front. And we're trying to give everybody visibility into what that context is and give them the opportunity to change that context if they so deem appropriate before we've gone off and actually done the work. But once we have that design file, once we have those requirements files, once we've laid out what the tasks are, once we've coupled that with our steering files, we've got a fairly high deterministic output in the sense that we've covered all the gaps. We've closed a lot of the variables that the LLM would normally have to go off and figure out for itself. So it's still not 100% deterministic. There's still room for variability, and that's why we don't want it to remove the human in the loop. We don't want Kiro to just take this code and deploy it into production, sight unseen. We still want to do our pull requests or our code reviews and those types of things. But we want to have what we are trying to solve for here is a lot of wasted time reviewing code that is obviously wrong because the context wasn't specified up front. And so by doing this work up front, we can cut down on the amount of wasted code generated, and we can improve the likelihood that a particular pull request can be approved as is and merged in.
Yeah, and the other thing I'll say to that too is the actual code that's written, right? If he were to take the spec file, these requirements, and blow away all the code and regenerate it, it's going to look different each time he does it. But that's implementation details, right? The requirements stay the same. How those requirements are satisfied is strictly implementation details. And what we're doing here, I think in essence, is abstracting away the details of the code and focusing on the business requirements and acceptance criteria. Because the actual specifics of the code implementation, while able to change, is not as important as satisfying the requirements. And that's where you're going to see the consistency. I haven't come to this side of the room, so I'm going to start over here because they've been ignored so far. What you got?
How do you share things like hooks across projects?
Hooks across projects.
Hooks across projects are shared by the fact that they're checked into the repo. So, you asked how do you share them across projects, not across developers. So the way in which you share hooks across projects at the moment is that you have to copy that hook into another project. You take that JSON file and you copy it into another project. That's not a particularly scalable approach, and we do have some things on the roadmap and in the pipeline to make those things more manageable at the organization level, to be able to push those down from an administrative level. But today, in order to share hooks across projects, you'd need to replicate the JSON file into the appropriate repo.
My question was
Kiro ran into some issue. How reliable is this? How often do we run into this?
How reliable is Kiro?
How reliable is Kiro? Well, normally I would tell you that it's very reliable. Now, obviously, it struggled on the generation of that agent hook. The issue with Node, I think, is actually a local problem on my machine, which I will figure out after this session. But generally speaking, Kiro is fairly reliable in the sense that it has a good understanding of the source code, and it generates source code fairly reliably. You'll also find, in many cases, when it does run into a challenge, and you could see this actually in the task that we completed, it ran the command and it said, oh, you don't have Node installed. And so it actually self-corrected there, and it said, well, let me try something else. And it tried that, and that didn't work either because I don't have NPX installed either, apparently. And so then it said, all right, well, now I'm going to go and I'm just going to generate the code for you manually. And so I'm going to skip that step and I'm going to keep going. And the point that I want to make there is that these LLMs are designed to be helpful by nature. So they want to produce results for you. And so given the context that's there, they're getting increasingly intelligent in how they work. And so they're going to try a particular strategy. And if that strategy doesn't work, they're going to move on to a different strategy. And they're going to problem solve along the way. And so generally speaking, Kiro is pretty effective in that regard in saying, hey, this is the approach that I want to take. Wait a minute, this approach didn't work. Let me try a different approach and see if that solves the problem. And I'm going to keep going. And at any point, I can step in and I can intervene and I can say, you know what, you're right, I forgot to install Node. So let me pause you right here and go take care of that. And then pick it back up again and have you keep going, rather than trying to solve for something that I obviously know is not right. So generally speaking, Kiro is pretty reliable in that sense, this particular example notwithstanding.
All right.
So if I want to make a change to a requirements document, do I directly do it in that document, or do I ask Kiro? If I'm directly making a change, does Kiro check whether it will break any other part?
Yeah, so the question there was, if I need to make a change to the requirements document, so in this particular case, we have this spec, and we've actually started building the code. So we actually have already run the first task in the task list. So what happens now, as is common in life, somebody comes back and they say, hey, this requirement changed. We don't want red, we want blue. And we need to make an adjustment. What do I do? How do I actually implement that? There's two ways you can do that. You can actually come back into the prompt and you can say, Kiro, I need to make an adjustment to this spec. I need to change it from red to blue. And Kiro will go off and it will make that change for me. Or I can manage, or I can change it manually. I can say, you know what, I want to get the planned date here and also a planned location. And if I put that change in there manually like that, what I can do is I can hit the refine button up here. And when I hit the refine button, what Kiro does is it actually goes and it evaluates the change that I just made to that requirements document. And not only is it going to refresh the requirements document to make sure that this is logically consistent, because I only changed it in one acceptance criteria, the likelihood is that this is probably going to need to be reflected in a couple different acceptance criteria. It's also going to make changes, though, to the design. So in the design document, we laid out what the models looked like, what the database tables looked like, all of those different things. Well, now we've gone and added a new attribute. So we're going to need to make an adjustment to that model. So we need to reflect these changes downstream. So we need to make the change not only in the requirements, but also in the design document. And given and potentially what this involves, if we had gotten far enough in the task list that we'd actually implemented those tables already, we'd actually written the code for them, we would then need to create another task to go in and modify those tables. And so we want to reflect that in the task list as well. So what Kiro does when we hit the refine button is that it says, all right, I see that you've made a change. I've gone through and I've validated it in the requirements. Now I'm going to move on to the design phase, and I'm going to make the adjustments there. And I'm going to carry that downstream. And if I need to create more tasks because we've already implemented this piece of the code, and I'll add some new tasks. If we haven't implemented this yet, then I can just modify the task and I can say, hey, do it the new way when you go and implement it. So I have a couple of different strategies there for how to deal with this. But generally speaking, that's how you would adjust for that. You'd make the change. You can either ask Kiro to make the change for you in the prompt, or you can do it manually and then hit the refine button and let Kiro run it through downstream. Correct. And it's going to trace that downstream.
I see that he created a few architectural diagrams. Can he understand these diagrams if I provide mine for him?
Yeah. So two strategies there. It created architectural diagrams in the design document using ASCII text here. And so you can provide ASCII text files that have similar design diagrams, and it can infer those. You can also just draw a design document on a whiteboard, take a picture of it, and upload it as an image file, and then have it say, go and implement this architecture diagram based on this image, and it will evaluate the image file, infer the contents of that image, and go off and actually do the spec or the implementation based on that. So you can do it based on either ASCII text, those types of implementations, or you can do it based on an image file like a PNG or a GIF or whatever the case may be there. Yeah, if you have a lucid chart, you could do that, most likely with a screenshot uploaded of the lucid diagram, and then use that.
I have a question. You said a project can have more than one spec. Right?
Correct.
Where is the boundary? How do you define spec?
What do you mean, how do you define a spec? Yep. So I want to I want to add an authentication layer to my fitness tracker app to keep track of which user is doing the activity. I'm going to, again, put this into spec mode. I'm going to type in my prompt here, and I'm going to hit go. And what it's going to do here is that it's going to create another spec for me. And so I've got a couple things running here. It's going to go and it's going to create another spec. So these specs here are laid out. I've got a spec directory, and I've got a subdirectory here for the fitness activity tracker. And so that subdirectory there has my design file, my requirements file, and my tasks file in it. Now I've kicked it off, and I've asked it to generate a new spec for my authentication layer. So now I'm going to add a new feature to my existing application. And so now what it's going to do is it's going to start building out a new spec for me, and it's going to say, oh, it's actually making changes to the existing spec for me because I haven't implemented it yet. If it were to build another spec, it would just create another subdirectory there with three new files: a requirements file, a design file, and a tasks file. Sure. The question is around best practices. What's the best way to think about a spec or how to treat it? Generally speaking, the way, and Ryan, you may have different opinions on this, but generally speaking, the way I treat a spec is I treat it as a bounded feature. So in this case, an authentication layer. And that feature has a specific set of things that I want to get done. If those things are not done yet, so in this case, we've got a whole lot of tasks that haven't been implemented yet, and something changes. I need to add another field. I need to change a color. then it makes sense to go in and modify that spec. Add the feature, whatever. If that spec is done, all the tasks are done, they're finished, and we've completed that spec, and now you come to me and you say, hey, I want to add another thing to it, I want to make a change. Generally speaking, what I would do is create another spec there. So that spec is done, it's finished, we're going to put a bow on it, we're going to slide it over to the side, and now we're going to create a new spec for this new thing, whether it's a change, whether it's a new feature, we're going to create a new spec. So I generally try to treat my specs as kind of contained entities. So when I've done the work there, I slide it over, I say this is done. If I need to make any more changes, I'm going to create a new spec, and I'm going to deal with it there. So that I have this kind of running list of specs. You technically can go back and modify an existing spec, even if all the tasks are done. But I find that makes it really muddy to be able to keep track of the work I've done and how I've done it, and to manage it that way. So I don't know if you have any other thoughts on that, but.
No, I mean, I definitely think it's more art than it is science. I mean, there's obviously going to be general, don't put too much into it, right? Like you have to get a sense. I think what you put into spec also influences how you organize around that spec. While there is collaboration aspects of it, I don't think I can divvy up a spec to 3 different teams, right? So think about boundaries of the way you work, how you work, and the other, I think to emphasize your point, is clear exit criteria, right? Like it's not an ongoing thing. It's a defined thing that we know we have concrete, discrete acceptance criteria that we can call done, essentially, the acceptance of done, and then ship it before we create another one. So they're not long living, they're organized around how we are organized. And I mean, I don't know, Fibonacci, I wouldn't put in more than, I don't know, 21, is 21 Fibonacci? I don't know, I'm just making that number up. Nothing too big. Yeah.
Question. Yeah, what do you do with the developers who are using something other than VS Code and who would rather die with their Vim application than migrate to something newer? It's a fair question, and there isn't a great answer for it. The Q Developer has a number of different plugins that can be installed. We have a JetBrains plugin for Q Developer. What we have found, though, that is trying to maintain plugins for every conceivable IDE under the sun is a very complicated process, and you end up with a lot of leapfrogging and lack of parity between them. So the strategy that we have generally gone to there is to recommend the CLI. So the CLI allows you to do a lot of these things directly from the terminal, and you can open up a terminal window in JetBrains or in Eclipse or in VS Code, the native version of VS Code, or in Visual Studio, and you can do whatever work you want to do there, and benefit from the generative AI capabilities there in the CLI, and that's generally the strategy we would propose there, and understanding that that's not entirely the same experience as what you have here, but it allows you to keep your preferred IDE and still get some of those benefits. It does come with the CLI. Yes. How do you prevent Kiro from hallucinations? So hallucinations really are a product of the model and how good the model is and the training data in the model, and then the context that the model has in responding to the prompt. The models that we are using have all been vetted. So Kiro doesn't have a bring your own API key strategy to it. So we have a predefined set of models. We have support right now for Sonnet 4, 5, and 4. We have support for Haiku, and we have support for Opus. So those models are there, and we've vetted them, and we've made sure that they generally understand the context well. And then the steering files and the spec files add the necessary context. It doesn't guarantee that you won't see hallucinations, but it does reduce the load fairly substantially.
And the second part was, are you going to open it up for like local LLMs?
We are looking at local LLMs, but they will, if we do that, they will be defined the same way we define our remote LLMs as well. So there will be a defined set of LLMs that you can use that would work there. All right, I think we have run out of time here, but I appreciate everybody coming out. Hopefully you found this useful. We didn't succeed in building a fitness application, but hopefully you get a sense for how you would approach that and walk through that process. And I will make sure I have Node installed next time. So thank you, everybody.